that one is perfect. Now let's take a look at C. In C, we have something a little bit fancier. We've got a square root. So this may look at least a little bit messier. So we're going to start by writing our formula for the difference quotient, which is f of x plus h minus f of x all over h. So when we're taking a look at f of x plus h, again, as a reminder, what that means is wherever there's an x, we're going to replace that with an x plus h. So what that will look like is our big square root will have where the x was, now it'll have an x plus h. Again, we're plugging something in, so let's put parentheses around it. Then it, remember, had a minus 2 inside of the square root. So that is our entire f of x plus h piece. You can technically put parentheses around the big square root here, but you don't have to because the square root already keeps things together. But you could put parentheses around it if you want to. You just don't need to. The square root holds things together for you. Then we have our minus sign, and then we've got an f of x. Well, remember, what is f of x? It's just the original function. So the original function was the square root of x minus 2. It means I'm just going to plug in a square root of x minus 2. And let's see, we are getting there. And then there is just the h that was on the bottom that I can't lose. Okay. So that wasn't too bad actually doing the plug-in stuff. The problem is this looks messy. There's an h on the bottom. I don't have a clue as to where to start here. Well, what's weird whenever we have square roots is we're going to use the same trick, always. That's at least nice. But what it's going to do is it's going to make things look worse first before we're able to actually make them look better. So I'm going to recopy what we have down here. We have x plus h, and I don't need the parentheses because there's nothing out in front of them, minus 2 as our first piece, minus a square root of x minus 2, and we have an h. So what's the trick we're going to use? Well, we just use it in one of the earlier sections in this chapter in 1.3 when we were dealing with i's. It was called a conjugate, which is we're going to actually take the entire piece with the square roots and look at the sign in the middle, which is a minus sign, and we're just going to do the opposite. So if there's a minus, we'll do a plus. If there's a plus, we'll do a minus. This is the trick we're always going to use when we see crazy square roots everywhere. And we will use this trick quite a lot in this class. So it's not worth blowing off here. So we'll take the square root of x plus h minus 2. So notice that doesn't change. And we will also leave the square root of x minus 2 alone. The only thing that's changing is that symbol in the middle is going to change from a minus to a plus. So we've got this times this new piece. However, remember how math works. Whatever you do to the numerator, you have to do the same thing to the denominator. So I still have to multiply the bottom by the same exact messy piece. The x plus h minus 2 under the square root plus an x minus 2 under another square root. And like I said, this does make it look worse before we can actually make it look better. Continuing along, what this means is now we don't need to simplify this at all. Now on the bottom, we've got an h and this messy guy. And we're going to just leave it as is. Just leave the h there, and then with the parentheses, the square root of x plus h minus 2 plus the square root of the x minus 2. We don't want to multiply it out. We're just going to leave it like this. And we'll see why later, is that we're hoping that this h that's down there, remember he's the problem because he's alone on the bottom, is that hopefully we can get rid of him. Well, be careful. That means we still have to multiply out the two pieces on top. How do we do that? This is not going to be pretty. We have to FOIL. So let's see what happens when we FOIL. So first thing that when we're FOILing is the square root of x plus h minus 2 times the square root of x plus h minus 2. Those two will get multiplied together. That looks awful. But they're the same square root. What happens when you multiply two identical square roots is that the roots disappear and you're just left with whatever's underneath. So we'll just have the x plus h minus 2. So that wasn't too bad. The next part in FOIL, I'm not really worried about, even though it looks horrible, is multiplying out the x plus h minus 2 square root times the square root of x minus 2. The reason why I'm not worried about it is the other middle term in FOIL, multiplying the square root of x minus 2 times the square root of x plus h minus 2 is the same piece. One will be a plus and one will be a minus, though, so they will cancel out. So in the first FOILing, we get the plus, the square root of x plus h minus 2 times the square root of x minus 2. But when you do the second part of FOIL, you get the same exact thing with a minus sign. Which means, what about those two pieces? It means if they're exactly the same, no matter how messy, if one's a plus and one's a minus, they will cancel out. The last part of FOILing is taking that square root of x minus 2 times the other square root of x minus 2. Well, first of all, we have to be a little bit careful. We have a negative times a positive, which will be a negative. However, when we do multiply those two square root of x minus 2's, remember they're identical, so the square roots will fall off and you'll just get the x minus 2. However, when the square roots do fall off, we still need to keep the x minus 2 together. How do we keep it together even though we've lost the square roots? Well, we have to pick up a set of parentheses. So I know that still looks super messy, but we are almost there. Because at least these two middle pieces canceled out. So those are gone. These two canceled out. One was a plus and one was a minus. And my first piece, that x plus h minus 2, there's nothing I can do with that. However, the second piece, as long as I did remember my parentheses, this will happen is I've got a minus sign out in front. So I'll get to distribute that minus to what's inside. And what that will get me is a negative x plus 2. And I'm still going to leave my denominator just horribly messy as that h times the square root of x plus h minus 2 plus the square root of x minus 2. And we're about to see some magic happen here. Because notice what happens next. We've got an x that's a positive and an x that's a negative up on top. So those two will add up and cancel out because one's a plus and one's a minus. Also up there we have a negative 2 and a plus 2. Those again are opposite, so they will cancel out. So what does that leave me with? On top, I'm only left with a positive h on top. So let's rewrite what we have left. So we've got the h on top. We've got the h on the bottom, the square root of x plus h minus 2. Plus the square root of x minus 2. Well, notice my problem is hopefully going to go away now because I've got an h on top and an h on the bottom that are both alone, so I can cancel those out now. So the h's will cancel out. So that does leave me with a messy denominator, but it's not too bad, is it leaves me with the square root of x plus h minus 2. Plus a square root of x minus 2. And now what's going to be hidden up on top is a hidden 1. Remember, if there is a 1 on top of our fraction, we do have to write that. We can't just make that disappear. The only way we can make it disappear if it was just a 1 by itself on the denominator. So, why is this okay? Because in this version, the h was by itself. And if we plugged in 0 on the denominator, we'd get 0 times something, which would be 0. Remember, we can't divide by 0. This one's okay if we were to plug in 0 for the h, because we just end up with another x minus 2 underneath our square root. And that's going to be kind of to give you a preview what you'll do in calculus. You'll want to be plugging in 0 for the h. That's why that solo h that always starts out on the bottom has to disappear at some point. So your final answer is this 1 over the square root of x plus h minus 2 plus the square root of x minus 2. I know it looks messy, and I do know normally we don't like having square roots on the bottom, but as long as the h isn't on the bottom by itself, that is really all we care about with the difference quotient. So we don't care that there are square roots on the bottom for like the first time and probably the only time in this course when we're doing the difference